This is Geometry Lesson 3.3. We're looking at adjacent and vertical angles. So the big idea here says a basic property of angles is that the measure of an angle formed by the outside rays of adjacent angles is the sum of the measures of adjacent angles. And so we'll get to that in just a little bit. But first we need to take a look at what are adjacent angles, some special properties of them, and then we'll also look at vertical angles. So the definition of adjacent angles: two non-straight and non-zero angles, okay, so we're not talking about straight angles or zero angles, are adjacent if and only if a common side is the interior of the angle formed by the non-common sides. So we need to make that make sense. If you take a look at the picture right here, these are adjacent angles, COB and BOA. They are adjacent angles. The basics of it is that they're next to each other. Okay, this angle and this angle are next to each other. But let's break down this definition. It says if a common side is the interior of the angle formed by the non-common sides. So with these two angles, COB and BOA, this ray right here, BO, or OB I should say, that's the common side. Common meaning they share it. Both of these angles use this ray as one of their sides, this angle and this angle. Okay, so a common side is in the interior of the angle formed by the non-common sides. So if that's the common side, these are the non-common sides, these two rays. And that creates one other big angle, COA, if we got rid of this middle piece here, this big angle, COA. All right. So the common side is in the inside or the interior of the angle formed by the non-common sides. All right, so it has to be on the interior first of all. And we've talked about interior here is less than 180. Exterior is the angle formed out here, the rest of the 360. So when we get to some questions later, they're going to be asking you if things are adjacent. Just because they're next to each other, two angles are next to each other and they share a side, doesn't necessarily make it adjacent. One other thing you got to look at is it in the interior, not the exterior? And so you're looking at, is the big angle that they both make together less than 180 or is it more than 180? So to be adjacent, technically, the two angles put together, the bigger angle has to be less than 180 based on this definition. Now, the basics of it though, they're touching, okay, they're sharing a side, that's adjacent. And the big thing we're going to look at is if I take this degree measurement plus this degree measurement, I get the whole thing. And we've done that with segments already. You break a segment into two pieces, you can add the two pieces together to find the length of the whole thing. We're doing the same thing now with angles. All right, some special adjacent angles. Angle bisectors. So when you bisect something, bi is 2, you're cutting it into two equal pieces. So you can see right here, VR, this ray right here, bisects PVQ. So the big angle is bisected by this ray, and that means it's cut perfectly in half. It has two equal angles now, so bisects means that. So VR is an angle bisector of angle PVQ if and only if ray VR is in the interior. Okay, so it's got to be on the interior. Again, less than 180, not out here on the exterior. And the angle of PVR is equal to RVQ. So I think it's easier just to look at the picture. You've got the big angle, PVQ. You've got a ray on the interior of it, not the exterior, the interior less than 180. That cuts that angle perfectly into two equal pieces. That is an angle bisector. All right, the angle measure postulate. This refers back to the big idea now. It says if angles AVC and CVB, so these two angles, ABC, CVB, if they're adjacent, and they are, okay, they share a side, and the angle that they're both a part of, this bigger angle, AVB, is less than 180. It's an interior angle. So these are considered adjacent. So if they're adjacent, which these are, then the measure of AVC, this angle right here, plus the measure of CVB equals the measure of AVB. So basically, if I take this one plus this one, I get the measurement of the whole thing. So think of it like two pizza pieces here. If I want to know how much pizza there is total, I take this slice plus this slice, and I've got the whole thing. So that's your angle measure postulate. You can add these together to get the entire magnitude here, the degree measurement. And you could do the opposite. If I knew the whole measurement of AVB, and then I had this little measurement in here, I could subtract those two and try and figure out what this one is. So we'll practice some of those. All right, some more important definitions. Complementary and supplementary, and we're going to talk about these nonstop in geometry. You got to know these. So we're talking about two angles. They can sometimes be attached to each other, but sometimes they can just be separate angles. Complementary and supplementary, just they add up to something special. Complementary angles add up to 90 degrees. So these two right here are complementary. 60 plus 30 is 90. So if the measure of two angles are r and s, then the angles are complementary if and only if r plus s equals 90. So these are considered complementary. And we would call them supplementary if they add up to 180 degrees. So this angle and this angle are supplementary. 60 plus 120 is 180. Most of the time when we're talking about these types of angles, they're connected in special ways in a picture to create 90 or to create 180. But it's not just limited to those special cases. Any two angles that add up to 90 are complementary. Any two angles that add up to 180 are supplementary. Okay, and then a very basic angle measure theorem. This one should make sense. If two angles have the same measure, their complements have to have the same measure. So if two angles are both 30, well, each one of those angles, their complements are going to be 60. That makes sense. If two angles have the same measure, their supplements have to have the same measure. So if I have two 120 degree angles, both of those have a supplement of 60 degrees. It just makes sense. So suppose you're given two angles, A and B, and the measure of angle A is equal to the measure of angle B. So they're equal. If the measure of a complement of angle A equals 5x plus 20, and the measure of a complement of B equals 3x plus 40, what is the measure of a supplement of B? So the first thing we need to look at is the fact that if these angles are equal, we don't know what the measure is, we just know they're equal, then that means their complements are also equal, like we said up here. If two angles, we don't know it, but if they were both 60, then their complements are both 30. They're both going to be equal to each other. So when I go to set this up and solve, I'm going to eventually have to find the supplement. But first thing I need to do is find out what x is, and then use that to help me find out how many degrees each one of these are, and then I can find the supplement of them. So let's start with the fact that we know these are equal to each other. Complement of A, complement of B. Since those angles are equal, so are their complements. So we can set up an equation that says 5x plus 20 equals 3x plus 40. We know those angles have to be equal to each other. So then we're going to quick solve this. So x equals 10. Now we got to use this information to go solve the problem. So we got to find the supplement of angle B. Only way we can do that is if we know what angle B actually measures. So we know that the complement of B equals 3x plus 40. So if I go ahead and plug this in, I can find out what the actual degree measurement is of that angle. So 3 times 10 plus 40. So 30 plus 40 equals 70. Now that's not the measure of angle B, that's the complement of B. Complements add up to 90. So if the complement of B is 70, that means that B has to be 20, because 20 plus 70 is 90. Now that I know that, I can find the supplement of B. That's the angle that adds up with it to equal 180 degrees. So if this is 20, the supplement has to be 160 degrees. So real quick again, how did I get through all of that? Two angles are equal. We don't know how much their measurements are. But we know that the complement of one of them is this, the complement of the other one is that. Since they're equal, the complements have to be equal. So I set those equal to each other, I solved for x. Once I had x, I plugged it back in, I figured out exactly what this angle measurement was, not angle B, but the complement of angle B. So if the complement of angle B is 70, that makes B 20 because the complements have to add up to 90. And then once I know that angle B is 20, I know the supplement of angle B, the angle that adds up with it to create 180, is 160. All right, when you flip it over, now we're going to start looking at some of these special cases, complements and supplements that show up in a picture. Not separate angles, but we can see a straight angle basically split up into two pieces, and that's going to be called a linear pair. So two adjacent angles are a linear pair if and only if their non-common sides are opposite rays. So the non-common sides of angle 1 and 2 are these two sides. The common side is what they share. And VA and VB are opposite rays. If I took away this ray, VC, the angle BVA is a straight angle. Okay, all of that is half of a circle, which means it's 180 degrees. We got another 180 degrees on the other side. Full circle, 360. So we're talking about angles 1 and 2 because they are splitting up a straight angle, which equals 180 degrees. I know that these two added together have to equal 180. So the linear pair theorem says if two angles form a linear pair, and linear means a line. So we have a line, a straight angle formed by a line, which is 180 degrees. Linear pair means two angles on one side of a line. We know they are supplementary because we know a straight angle is 180 degrees. A linear pair is splitting up that 180 degrees. So if I add them together, they have to be supplements. They're going to add up to 180. So if I knew that this was 150 degrees out here, just by looking at the picture, I'm allowed to assume, we've talked about what are we allowed to assume in these pictures. I can assume that this whole thing is 180 degrees because I have a straight line. So I know automatically this is 30 degrees. These two angles have to add up to 180 because they are splitting this up into two pieces. Okay, vertical angles, some more special angles. Two non-straight angles are vertical angles if and only if the union of their two sides is two lines. So let's start with angle 1. We got to find the vertical angle based on the definition. The union of the two sides. So here's the side of angle 1, and that line continues out this way. That's part of angle 4 and angle 3. And then this other side that creates angle 1 is also part of the line that creates angle 3. And so angle 3 and angle 1 are using the same exact lines to create their sides. So angle 1 and angle 2, angle 1 and angle 3 are vertical. And then out here, angle 4 and angle 2 are vertical. Again, the sides that are creating those angles, angle 2 and angle 4, are shared sides. This line continues and it creates the side of angle 2. This side of angle 4 continues, that line continues and creates the other side of angle 2. So both sides of angle 4, if you extend those lines, create the two sides of angle 2. Those are vertical. Now that can be a little confusing, but basically what happens is, if we just want to break this down to make it simple, when you have two lines that crisscross like this and make an X, the angles that are on opposite sides like this are vertical. And the reason we're talking about them specifically is because if two angles are vertical angles, their measures are equal. So if I know that this is 160 degrees, angle 4 is 160, I automatically know I'm allowed to assume that angle 2 is also 160. Now if you look at this picture, 4 and 3, if I just got rid of this for a second, make it simple, 4 and 3 sit on a line. Those are a linear pair. Together, those have to equal 180 degrees like we talked about up here. I've got a straight line Angle 4 and angle 3 make up an entire side of that straight line. Those are a linear pair. They add up to 180. So I know angle 3 must be 20 degrees because it has to add up to 180 with this one next to it. And now since these are vertical, I know they're equal. And if I add up all of these, 160 and 160 is 320, plus 20 is 340, plus 20 is 360. All the way around, I've got a full circle here. These have to add up to 360 degrees. So opposites or verticals here are going to be equal. Linear pairs are going to be supplementary and add up to 180. And a full circle now is going to equal 360. All right, so from all those theorems now, we can start to look at some pictures and figure out what angles are equal to. So from the drawing at the right, determine what the measure of angle DAE is. So from D to A to E. That's all of this angle out here. So basically it's been cut into two pieces. Think of it like kind of like a pizza. These two angles here, the 90 and the 35, make up this entire bigger angle, DAE. So we know that 35 plus 90 is going to give me this measurement here. This angle plus this angle has to equal the whole thing. So when I add those together, that is 125 degrees. What about the measure of BAE? BAE. How in the world am I going to find that? Well, I know my dots here don't make it look like a perfect circle, but this is a full circle. This whole thing is going to have to equal 360 degrees. And this is the only one I'm missing. So if I take 360 and I minus 104, and then I can do these individually, minus 35, minus 90, or I can combine them like I've already done and minus 125. But I'm going to go ahead and write them separately. So if you look back at your notes, you can see we're subtracting all of these pieces. Whatever's left is what's remaining here. So 360 minus 104 minus 35 minus 90 equals 131 degrees. This has to equal 131 degrees, so that all together we get 360. Okay, and then part C, we're going to name all the adjacent angles. So going back to adjacent, they have a common side, and the non-common sides are less than 180 because the common side is on the interior of the angle. So as we look at all of these, we've got this one and this one that share a side. We've got this one and this one that share a side. This one and this one share a side. This one and this one share a side. So we have to just look closely. Let's start with the ones that are obvious, that are less than 180. These two that I labeled 1 and 2 earlier, okay? The bigger angle is less than 180. We already know it's 125, DAE. They share a common side. These two angles touch. They share this ray. Those would be considered adjacent. So how do we write that? So we're naming the adjacent angles. So angle DAC, that's the one I labeled 2, that's 35 degrees, is adjacent to this angle, CAE. That's one pair. These two right here share a side, and the bigger angle that combines both of them is less than 180. 104 plus 135 is less than 180. So these would be adjacent angles. So that's angle BAD, this one out here, BAD, and DAC. Now, trying to find some more of them, this angle and this angle share a side, but 90 and 131 is more than 180. So these two would not be considered adjacent, even though they do share a side, because the bigger angle that makes up those two together is more than 180. So that this shared side is not on the interior of that angle. It's on the exterior. So this bigger angle, CAB, the interior is the part that's less than 180, and this shared side is not in there. So these would not be considered adjacent, and the basics is together they add up to more than 180. Same thing out here. These two angles, they do share a side, but together they add up to more than 180, which means that shared side is not on the interior. It's no good. So the only adjacent angles here are these two, which we've already named, and these two. All right, and then down to the bottom. Looking at this one, so these are a linear pair. You need to notice that right away. We have the straight line. It's the same picture that we used from up here. We have a straight line, and we've got this vertex V. BVA is a straight angle. Okay, it's cutting a circle in half. So we're going to have 180 on this side, 180 on this side. So these two angles, angles 1 and 2, are a linear pair, and they're supplementary. They add up to 180 degrees. So the measure of angle 1 is 52. If the measure of angle 1 is 52, what's the measure of angle 2? So we know they got to add up to 180, so you're going to do 180 minus 52, and you will have the other angle. 128. So this would be 128. All right. And then if the measure of angle 1 equals Q, so instead of 52, it equals Q. What's the measure of angle 2? So students always get confused. We've talked about this many times. As soon as you change it from a number to a variable, people shut down. But they already gave you the problem with a number. So look back and think about what you did. When I told you this was 52, you did 180 minus 52. So if I tell you it's Q, what's the measure of angle 2? Do the same thing you did to the number, but to the variable. So instead of 180 minus 52, it would be 180 minus Q. And there's no solving it. Okay, if the measure of angle 1 is Q, we know the measure of angle 2 is 180 minus that measurement of Q, because together they have to add up to 180. So that would be your expression for angle 2.